It stands as a silent monument to failure, a gleaming $1 billion marvel of modern engineering, stretching for miles across the water, complete in every way. There's just one problem. It has no cars, no trucks, no people. It's a pristine artery with no pulse. Built to connect a nation, it sits empty, barricaded, and abandoned after it was finished. Why? Because shortly before its grand opening, engineers discovered a single, terrifying flaw. A mega defect so profound, it turned this billion-dollar triumph into the most expensive and embarrassing piece of modern art in the world. This bridge is the ultimate example of a hidden vulnerability, a single overlooked flaw that compromised an entire billion-dollar system. Your digital life is no different. You might have firewalls and passwords, but a single unseen vulnerability can expose your entire system to catastrophic failure. Protecting against these hidden defects is essential. That's why I secure my digital connections with NordVPN. NordVPN creates a powerful encrypted tunnel for all your internet traffic, shielding your personal data from hackers, surveillance, and prying eyes. It's the structural integrity for your online life. Beyond just security, NordVPN gives you the freedom to bypass geo-restrictions, granting you secure access to the global internet, no matter where you are. With thousands of high-speed servers and a strict no-logs policy, NordVPN ensures your connection is fast, stable, and completely private. Don't wait for a critical failure to realize you're vulnerable. Secure your digital foundation today. It began with a grand vision, a bold, iconic bridge to overcome a major geographical barrier, symbolizing progress and uniting a region. The design was revolutionary, the longest span of its kind, using state-of-the-art materials and an ambitious engineering approach, focused on minimizing weight and maximizing aesthetic appeal. Billions were allocated, and politicians made grand speeches. For years, the engineering world watched as the bridge rose from the water, an extraordinary feat of engineering, requiring massive deep-sea foundations and miles of high-tension cable. The media hailed it as a modern triumph, seemingly on schedule and on budget. Engineers openly celebrated its completion, viewing it as validation for their aggressive design choices. By year, it stood complete, a gleaming, perfect billion-dollar bridge, ready for its grand opening, a testament to seemingly faultless ambition. The eventual failure wasn't entirely unpredictable. During construction. Subtle red flags, minor, anomalous vibrations, or unexpected structural movements during moderate winds were reported by on-site teams. These were often dismissed as settling or construction noise in the rush to completion. The profound irony is that this specific type of failure was meticulously documented 80 years prior with the catastrophic collapse of the Tacoma Narrows Bridge, or Galloping Gertie. The engineering world spent decades learning about aerodynamic flutter and resonance. Yet this modern structure used ambitious, untested parameters that minimize structural redundancy and maximize the deck's surface area. The designers unknowingly created a highly susceptible structure, ignoring a multi-million-dollar, life-saving lesson from the past, convinced their superior materials and computer modeling made them immune. They failed to acknowledge that natural forces are indifferent to computer code. The truth finally emerged in a final, meticulous round of dynamic stress testing, mandated just weeks before the ribbon-cutting independent engineers, verifying the bridge's response to lateral wind loads, discovered a horrific flaw. Computer models, simulating wind speeds far below hurricane force, showed the deck would enter a self-exciting oscillation, a torsional flutter that would build exponentially until the span broke apart. The bridge was fundamentally unsafe. The cost of failure was not hypothetical, it was guaranteed. This revelation sparked a secret, panicked crisis. The hubris of the revolutionary design had led to a beginner's structural mistake. The agonizing decision was immediate: open the bridge and risk an unthinkable, life-taking disaster, or admit they had just spent $1 billion on a perfectly engineered, useless sculpture. The grand opening was quietly postponed, then indefinitely suspended. The billion-dollar bridge, complete and pristine, was officially deemed too afraid to open, a powerful mega defect. The core mega defect lay in the bridge's aerodynamic instability, a direct result of its innovative but flawed geometry. The design featured a very high span-to-width ratio, making the deck extremely slender and prone to twisting. Crucially, the shape of elements like the guardrails or maintenance parapets along the deck's outer edges inadvertently created vortex shedding, predictable pockets of swirling air that exerted a rhythmic force back onto the deck. This rhythmic force perfectly matched the bridge's natural torsional frequency, setting up a resonance loop that would build exponentially until the deck's material limits were exceeded, leading to structural failure. The miscalculation wasn't a typo or cheap material. It was a fundamental misjudgment of fluid dynamics and structural interaction, a single critical error buried deep in the original design calculations that somehow survived every peer review and inspection. It was a failure of fundamental physics in a structure designed to defy limits. The political and financial fallout was swift and staggering. The silent bridge became a financial black hole, incurring lost toll revenue, disrupted commerce, and massive ongoing maintenance for an unused structure. Proposed fixes were nearly as astronomical as the initial cost. Hundreds of millions for hydraulic dampers, tuned mass absorbers, or radical changes to the deck's aerodynamic profile. Politicians furiously turned on the engineering firms, attempting to deflect blame. The firms in turn sued subcontractors, blaming material suppliers. The entire chain of responsibility collapsed into a costly legal nightmare. The bridge was not just a structural failure, it was a profound crisis of public finance and political trust. The money to fix it could have funded dozens of successful infrastructure projects. The firm's professional reputation, once stellar, was tarnished beyond repair. Insurance companies fought vehemently, citing design negligence, leading to a decade-long legal battle. The legacy of the firm became forever tied to the most expensive structural failure in modern history. A stark reminder that hubris has a measurable, catastrophic price. And so it stands, a silent, empty monument to our own ambition. The $1 billion bridge that was too afraid to open is the ultimate mega defect, a failure not of materials, but of complexity and institutional hubris. It's a terrifying lesson that in the rush to innovate, to build bigger and more spectacularly, we can overlook the fundamental, simple truths of physics. It teaches us that the most critical part of any engineering project isn't the steel or the concrete. It's the humility to check the math twice, to respect the lessons of the past, and to possess the courage to admit a flaw before it becomes a billion-dollar headline. The ultimate cost of the bridge was not paid in its construction, but in the lessons it now silently forces us to learn. What other colossal, white elephant projects do you know of that stand as a silent testament to human error? Share the stories of engineering hubris from your region in the comments below. If you found this investigation into a billion-dollar failure compelling, hit that like button, share this video, and make sure to subscribe to Mega Defect for more deep dives into the flaws of our modern world.